Let's do some homework help on the chapter 3.1 rocket launch problem. It gives us this formula: velocity at time t is negative gt minus v sub e, that's exhaust velocity, times natural log of m minus r times t over m. This is the way it's written in the homework, but it might help to write it this way. And g, v sub e, m, and r are constants, and t is our main variable of interest. So it says write the acceleration function, and acceleration is the derivative of velocity. So we want to take the derivative of this function. So you probably tried this already, but it's not a bad idea to do it again from scratch if you don't mind. All right, hopefully you're back from that. So g is a constant, and the derivative of t is 1. I could just write negative g. V sub e is a constant. What's the derivative of log? Log stuff is 1 over stuff, so 1 over m minus rt over m. And then times the derivative of that stuff, m minus rt over m prime. Do I need the quotient rule here? Well, m is a constant, so I can just use the constant vertical multiplier or divider rule. And we can do kind of a side calculation here. What is m minus rt prime? Well, derivative of m is 0. Derivative of negative rt is just r. So you can do that. So in this case, it helps to simplify a bit because we're going to take the derivative again. And taking the derivative of that would not be particularly fun, but you can do it. So right now I'm just simplifying. Minus g minus v sub e. We can flip this over m minus rt. And then we had a 1 over m coming out from there, and then a minus r for the derivative of the top. And then it asks for the jerk function. J of t is the derivative of acceleration. What's the derivative of negative g? Negative g is a constant, so that's just 0 minus v sub e. And then what's the derivative of m over m minus rt? Well, the m I can think of as a multiplying constant. Dividing by m minus rt is like taking m minus rt to the negative 1. So then I'd have a negative 1 m minus rt to the negative 2. And then times the 1 over m times negative r. Oh, and you know what I forgot? The derivative of the inside here. So times m minus rt prime. So then that's all that times just another negative r there. And then it says to graph it, so then we'll switch to Desmos to doing that. All right, here we are in Desmos, and we've typed in the formula we were given. Notice I've typed it in with all the parameters that were specified in the problem rather than typing in those values myself. That saves me time typing later, and I can just put the values here and I don't have them kind of lost in the formula. I don't have to type m twice and so forth. So we get this curve for v of t. It said from 0 to 60 seconds. And then the formula we got for the acceleration at time t was basically that. And that curve is here. It's on different units than vertically, because it's meters per second squared instead of meters per second. So to really see it, I should zoom in this way. And okay, so that's good enough. I can see the acceleration curve there. 10 meters per second squared of 9.8 is basically 1 g. So it looks like we're getting up toward 1.5, 2 g's, which is tolerable. You can do that on a roller coaster, for example. And then here's our jerk function. That again is on a different scale, y scale. It's at the meters per second cubed. So we can zoom in even more to see that. And I don't have handy what common values of jerk are. I guess we could look those up if we wanted. And we can check these by doing like a prime of t. Actually, so this is a Desmos thing. It doesn't know to put stuff about t on the horizontal axis. So you have to say like a prime of x. And we can see that those exactly overlap. You could do the same for v prime and a. All right, so rocketry is fun and easy, of course. Anytime I think about rocketry problems, I also think of what else was going on in like the Apollo era, 1960s, and there was actually a really interesting speech about the civil rights program and a civil rights movement and Apollo given by Ralph Abernathy, who is a leader of the civil rights program. So I encourage you to look up Ralph Abernathy and his speech at the Apollo missions.